Okay, now we're looking at number 10 on the practice worksheet for graphing exponential functions. And when there is no constant being multiplied times the base, then the a is equal to 1. Okay, then our base b is a 2. The h, since this is shifting to the right 3, h is equal to positive 3, and then the k is our constant being added at the end, and that's a positive 2. Okay, since the base is greater than 1, this is going to be an exponential growth function, and the asymptote is through k, so y equals positive 2 is the horizontal asymptote. And we can come over to the graph then and sketch that horizontal asymptote as a dashed line through y equals positive 2. Okay, now the domain of all of our exponential functions is negative infinity to positive infinity, and the range, because there's been no reflection, a is positive, the range starts at that asymptote and heads up to positive 2. So 2 to infinity unbounded is our range. Then the transformations, we're going to pick anchor points from the parent graph of y equals 2 to the x, and 0, 1 would be the y-intercept on that parent graph, then 1, b, and our b is a 2, and then negative 1, and the reciprocal of b, the reciprocal of 2 is 1/2. Okay, since the a is a positive 1, there's no sense multiplying each of these y values by 1 because they're not going to change. There's been no vertical stretch or shrink and no reflection. So we'll skip over the the a rather, and then we're going to add the h, which is 3, to the x coordinate of each one of these points. So 0 plus 3 is 3. 1 plus 3 is 4, and negative 1 plus 3 is 2. And then for the vertical translation, we add the k, and the k here is a 2, and we're going to add that to the y coordinate. So the x's of each of these points stays the same, and then the y, 1 plus 2 is 3, then 2 plus 2 is 4, and 1/2 plus 2 is 2.5. So we'll go ahead and plot those points on the graph, going to 3, 3, 4, 4, 2, 2.5. Okay, now we're going to pick the coordinates for 2 more guide points. We know 2, 3, 4, so let's put in 5 for the x to get a point to the left. And our original was 2 raised to the x minus 3 plus 2. So substituting 5 for the x, we get 5 minus 3 is 2, 2 squared is 4, plus 2 is 6. So the point 5, 6 would be on this graph. I can see this is going to be approaching this horizontal asymptote, so instead of picking a point on the left side of the x equals 2, I'm just going to keep going to the right and put in 6. So I'll have 2 raised to the 6 minus 3 plus 2, which would be 2 cubed, which is 8, plus 2, which is 10. So the point 6, 10, which would be way up here, is going to be my next guide point. And then we're going to bend, go through these points, and that would be a sketch of the function 2 to the x minus 3 power plus 2.